Okay, picking up again with number 13. I've got an equation, b equals 100 times 2 to the n, where n is the number of days, b is the bacteria. They want me to find the bacteria after 4 days, so I'm going to go ahead and plug in n equals 4. That gives me b equals 100 times 2 to the 4th power. And we need to simplify that. So using our order of operations, should we multiply or should we do the exponent first? Well, we know from PEMDAS we would do the exponent first, so I'm going to take care of this 2 to the 4th. That's 2 times 2 times 2 times 2. You could also use the caret button on your calculator, 2 caret 4, and that's going to give you 16. So I have 100 times 16. 1 times 16 is 16, and then copy over your 2 zeros. So I get b equals 1600. Since it's a word problem, I'm going to go ahead and put units there. So 1600 bacteria. Alright, moving on to number 14. We've got the person's heart rate, R, and X is the number of minutes that have passed since exercise has stopped. They want me to know the heart rate after 5 minutes, so that means x equals 5, so let's go ahead and plug that in for x. So I have r equals 4 times parentheses 10 minus 5 squared all over 5 plus 80. Alright, following my order of operations, I've got parentheses, definitely do that first, so 10 minus 5 is 5. Copy everything else. I know it's kind of a pain to copy it, but it's important. So we've got 5 there. Now I need to deal with the exponent next. So parentheses, then exponent. So 5 times 5, or use your caret button, gives you 25. So I have 4 times 25, all over 5, plus 80. Okay. Now I can multiply, so I'm still just focusing on the top of the fraction here. 4 times 25 is 100 over 5 plus 80. We're almost done. And last I'm able to divide, then add. So dividing, I get 100 divided by 5 is 20 plus 80 gives me 100. Okay, and that was 100. Let's see what was our beats per minute. So 100 beats per minute. Alright, so that one is done. That was kind of a long one. So you'll notice I'm just going really carefully, doing one operation at a time. Each step I just take care of one operation here. It's a really careful, organized way to do it. If you try to combine multiple steps, sometimes it's okay and you can save a little bit of time, but again, this is the most careful way to do it, to just make sure you're not breaking any of those rules with the order of operations. So going on to number 15. We have 20 snack boxes. Inside each box there are 3 granola bars and 6 bags of raisins. We want to know the total number of snack items. So we need to figure out which one of these makes the most sense. And it might help to not even look over there and just think about the problem. So in each snack box we have 3 granola bars and 6 bags of raisins. So I know that's going to give me a total of 9 snacks in my snack box. So I would have to add the 3 and the 6 first. And then I know there's 20 snack boxes, so after I add the 3 and the 6, I'd want to multiply that by the 20. And so let's see if that looks like any of these. Adding first, then multiplying by 20, and sure enough it looks like C right there. So I'm ready to do the math. 3 plus 6 is 9. Do the adding first, and then 20 times 9. 2 times 9 is 18. Carry over your 0. So I'd have 180 snacks total. Okay. Last one, number 16. The garden shop has 8 flats of strawberries. They received a delivery of 7 boxes, each of which contained 10 flats of strawberries. They stocked the shelves. 14 customers each bought 1 flat. Write an expression to represent the number of flats of strawberries remaining. Okay, so we've got 8 flats of strawberries. We've got a delivery of 7 boxes. Got to think through this one. 10 flats of strawberries. Okay, so that would be 7 boxes times 10 flats. That looks like we've got 70 flats after they stocked the shelves. 14 customers each bought 1 flat. Okay, so hold on a second. I think I'm going to make this one a new video. Pause with me.